Cusco, Peru, May 1950. The valley is still and quiet. A massive earthquake hits the Cusco Valley without any warning. 90 seconds. That's all it takes to change an entire city. 3,000 buildings across the valley collapsed into rubble. In the ruins, rescue workers find something that makes no sense. These ancient walls, built 5 centuries earlier, still standing. No cement, no mortar, not a single drop of binding agent. Just stone, fitted to stone, standing perfectly in place. How do walls without mortar survive what mortared walls can't? To understand all of this, we need to go back 500 years. Back to the Inca stonemasons, who figured all this out long ago. The Inca Empire sat squarely on one of Earth's most seismic zones. They didn't stumble here by chance. They were born into its earthquakes. Every builder, every stonemason understood one simple truth. The ground will shake again, so you plan for it, you build around it. But what does planning for earthquakes actually look like in practice? When you have no steel, no concrete, no tools, no calculations. That question led them to a solution so deeply counterintuitive. Modern engineers couldn't believe it until they finally measured it. One day in the 1430s, an earthquake struck Cusco hard. The damage was catastrophic, entire districts simply gone. Pachacuti ordered a complete reconstruction of the ruined city. But not just repairs, he wanted a full rethink of construction. His builders asked a question no civilization had ever asked. Not the old familiar question, how do we make walls that move? But a different one, how do we build walls that can move safely? Every other civilization had arrived at the same answer, mortar. Clay, lime, or bitumen, pack it between stones and lock them. The Inca saw what mortar does and made one clear choice, reject it. Mortar is rigid, and rigid walls shatter under seismic load. But flexible joints, they absorb the energy and then release it. Inca stonemasons spent days, sometimes weeks on one fit, fitting each block to its exact neighbor, entirely by hand. No machines, no measuring tools, just careful human hands. The result, ashlar masonry, and it's genuinely brutal work. Some of these individual stone blocks weigh over 100 tons. Some joints, you cannot fit a razor blade between the stones. Here's what actually happens when a major earthquake hits one of these walls. The individual stones don't resist the shaking, they move with it. Each block shifts just a fraction of an inch in its neighbor's grip. The seismic energy passes through the whole wall rather than into it. When the shaking stops, every stone settles back into place. Perfectly every single time, the Inca called this quality stones that dance, which sounds like a metaphor, but it's physics. It's actually seismic engineering, and it saved the empire. But rejecting mortar came with a cost nobody often discusses. Fitting 100-ton blocks by hand, with zero room for error. One mistake, and the entire wall section becomes unstable. You can't patch an Inca error with mortar, you have to start over. Pachacuti's engineers had to solve that problem. That's where the second idea came in, the one that actually looks like a mistake. Every Inca wall tilts inward between 3 and 5 degrees. Most builders throughout history would look at that and call it a flaw. The Inca built the lean as a feature, lower center of gravity. Harder to topple, seismic load pushed down, not sideways. Then came a third idea, the one that still surprises experts. Every doorway, every window in an Inca structure is trapezoidal. Wider at the base, narrowing at the top, leaning slightly inward. That shape distributes seismic load more evenly than rectangles. And it was everywhere, every entrance in the entire empire. Soon Cusco was rebuilt. The new city was genuinely smarter. The Palace of Coricancha, Great Temple of the Sun, rose from ashlar. Blocks fitted in an interlocking jigsaw pattern, not a grid. Not neat grid rows, an interlocking puzzle of unique shapes. The city stood, earthquakes came and went, the walls held firm. For 2 full hundred years the techniques worked, every single time. Then the Spanish arrived in Cusco, and they believed they could do better. They had mortar, they had right angles, they had enormous confidence. They built their cathedral directly on top of Inca foundations. And then the Spanish did something the Inca would never have considered. They filled the flexible Inca stone joints with mortar and concrete. They straightened the inward-leaning walls, fixed what they called the tilt. They replaced the trapezoidal doorways with rectangular openings. For a full century after all those changes, the city held firm. The Spanish construction looked strong, felt permanent, safe. It looked exactly like they had improved on what the Inca left behind. And then May 1650, another major earthquake hit Cusco. The Spanish cathedral, so tall, so solid, cracks immediately. Walls filled with rigid mortar have no flex, they don't dance. They break apart. The mortar holds the broken pieces as they fall. The Inca foundation under the cathedral, not one stone moved. The Spanish rebuilt, same mortar, same right angles, same methods. The same outcome was waiting for them, 3 full centuries later. May 1950, we're back to exactly where our story began. 3,000 buildings, 90 seconds, all collapsed to rubble. And here is what those rescue teams found when the dust finally cleared. Every structure still standing was built on an Inca foundation. The cathedral built over Coricancha collapsed to its stone base. The Inca stonework beneath it, untouched, perfect, still plumb. The same pattern that played out in 1650 played out again. Peruvian archaeologists mapped the entire damage zone that followed. What they uncovered beneath all the colonial rubble changed how we think about what seismic resistance actually means as a concept. The answer wasn't better materials. They used local andesite, the same volcanic stone available to any local builder. The answer wasn't strength. Inca walls aren't thicker or denser. The answer was a philosophy about what a wall is supposed to do. A seismic wave hits a rigid wall, and energy goes nowhere. It builds inside the structure until the wall shatters. When that same wave hits an Inca wall, the stones give slightly. The energy flows through the stone joints and quietly disperses. The Inca wall doesn't try to fight the earthquake, it dances with it. Remember those walls, still standing in the 1950 rubble. That's exactly why the stones danced, and then they came back. The Spanish quickly filled those Inca joints with mortar to fix them. They stopped the dancing, made everything rigid, and then it all broke. Researchers published a formal study on Inca stone masonry. They printed scaled models of the Inca interlocking stone joints. They put those stone models on a real seismic shake table in the lab. The Inca-style joint outperformed every modern method tested. 6 centuries after Pachacuti rebuilt Cusco, it still wins. Machu Picchu sits on 2 active fault lines, not by chance. The Inca chose that site knowing the ground beneath would frequently shake. They engineered for the earthquake, not around it, not despite. 60% of all Inca construction effort went underground. Drainage systems, deep stone footings, invisible but critical. The part you never see is what keeps everything above it in place. That's the real lesson, not the clever joints or the lean walls, or the trapezoidal doors. It's the philosophy behind it all. The best builders don't pretend the problem simply doesn't exist. They design around the deep truth of it, and for the Inca, that truth. The answer was this: the ground will shake, so build as though you know. What do you think was the most remarkable thing the Inca understood? The no mortar joints, or the 60% of it built underground.